Hi there, podcast and public radio fans. Heath Drusen here, host and creator of the Extremely American podcast. I'm working on season 3, which is an urgent story about neo-Nazi terrorists and how they helped build a modern white supremacist movement, even from prison. Some of their ideas have even made it to today's White House. It's both a gripping true crime story and a timely warning about threats to our democracy. And this time, my investigative reporting is funded by you. To support the project, please make a tax-deductible contribution at extremelyamerican.org. That's extremelyamerican.org. And thanks.
From the studios of Boise State Public Radio News, I'm Samantha Wright, filling in for Gemma Goddard, and this is Idaho Matters. Everybody knows Saturn has rings, and it turns out it's not the only planet with that distinction. Uranus also has rings, but they're not quite the same as Saturn's, at least some of them aren't. New research has uncovered 2 new rings, a red one and a blue one, and the blue one is made up of water ice, which is giving scientists some important clues about one of the weirdest bodies in our solar system. Uranus is already weird. It lays on its side in space. It rotates backwards compared to almost every other planet. And it's not a very pleasant place. It's made up of smoky fluid ice with winds up to 560 miles an hour and temperatures down to 370 degrees below zero. And we still don't know that much about it. Matthew Hedman is learning more about the planet every day. He's a professor in the Department of Physics in the College of Science at the University of Idaho. You might remember him from last November when he told us about finding a new moon orbiting Uranus, and now he's back to tell us about its rings. Matthew, thanks for coming back on the show.
Thank you very much for having me. It's a pleasure to be here.
Okay, so when did you start looking at the rings? I know you were already looking at the planet for other stuff. When did you kind of focus in on rings?
So we were actually looking at the rings at the same time we were starting to look for moons. The rings of Uranus are very odd, and the new data that we got from the James Webb Space Telescope just provided the clearest picture we had seen of these things in decades. So at the same time as we were poking around for new moons, we started to poke around to see if we could see some of the rings. And there were rings, like the ones you mentioned, that could be seen in earlier data, but were really difficult to pull out. And if you just stretch these images from JWST a bit, you could see them very clearly. And so we started looking at them in more detail.
Okay, so tell us about the 2 new rings and why they might be different from Saturn's.
Well, these 2 rings, which are called the Mu and the Nu rings, Uranus rings are named after Greek letters for historical reasons. They're different from some of Saturn's rings, but not all of them. The rings you see of Saturn are very broad and very opaque, which makes them easy to see even with small telescopes. Uranian rings can either be really narrow and really dark, which make them hard to see, or they can be very tenuous. And these 2 rings, the Mu ring and the Nu ring, are very faint and very tenuous. They're made of very fine particles that make them hard to see, except with very high quality instrumentation. And there are rings kind of like this at Saturn, but nothing exactly like these 2.
Gotcha. Okay, and you taught me a new word, Uranian.
Okay.
Okay, you've got the red ring, which is probably made up of sort of dusty bits, and the blue ring, which seems to have excited everyone.
Right. So many of the rings of Uranus have a roughly red color, and many things in the outer solar system have that color. It's just the nature of material in the outer solar system tends to be red. The Mu ring is unusual. It is blue in color. It's brighter at blue wavelengths. It is the only ring of Uranus that has that property, and it's also the only ring of Uranus that is made pretty much exclusively of water ice. And both of those are unusual for the Uranian system. And we're trying to figure out what it is because water is, of course, a very important thing for, life and just our solar system in general. Why does this one made of that? And it's, of course, tied to the thing that produces it, which is this tiny moon called MAB.
All right, so now you have to tell me about MAB and how MAB is, I don't know, throwing chips of ice at Uranus to make rings.
And yeah, this is a very strange little object. It's not very big. It's a tiny moon. It's only about 6 kilometers in radius, so maybe, 5 to 10 miles across. It is a small object. And there are many other moons orbiting Uranus, but none of them produce a ring like this. And so it seems to be unusual in that this moon is also very blue. It is also blue in color, indicating its surface contains a large amount of water ice. So something about this moon has a special composition and something, and we don't know entirely what yet, is causing it to launch material off of its surface so that it goes into orbit around Uranus. None of the other moons seem to do this at this level of efficiency, which is a very major puzzle. It implies there's something special about this moon.
Wow. Okay. And I think one of the theories I saw was maybe micrometeorite impact. So something hits MAB and then little bits fly off and create a ring.
That is totally a possibility. Just like, that thing that blew up above Boston earlier this week. Things crash into objects in the outer solar system all the time. We've actually seen it happen. We've seen collisions into Jupiter, into Saturn, etc. So it's not ridiculous that this object gets hit by stuff. Mm-hmm. And when you hit a tiny little moon with little gravity, material can be knocked off of it. And if you knock enough, it basically stays in orbit around the planet and becomes a ring. That is totally a possibility. The question then becomes, why this moon? There are other moons in orbit. Some of them are about the same size. Why are they not producing rings? To say, another possibility is that maybe this composition makes it easier to launch material off of it. Maybe it's a little more like comets than other objects in the Uranian system, for reasons we don't know.
Okay. Well, as we said at the beginning, Uranus is a really weird planet anyway. You mentioned that it has a lot of moons. We're talking a lot of moons. We're not talking like just a couple. We keep finding new moons. You found a new moon.
Yep, that we found. We recently found a entirely new moon. That's, I think, number either 28 or 29, depending on how you count. In orbit around Uranus, and there's still data coming in. There might be the chance to find a few more.
We're speaking with University of Idaho physics professor Matthew Hedman about his discovery of 2 new rings around Uranus. So how did you find all this out? This was kind of I read your study, but I don't have a PhD in physics, so I went a little blind reading parts of it. I guess my question here is, you didn't just look through a telescope and say, hey, that ring looks like it's made of ice. There was a lot of science behind this discovery, right?
Right. And just to be clear, other people had seen these rings before, so we weren't the first to see them. Mm-hmm. What we were able to do was use data taken by a bunch of telescopes, particularly ones in space, which are just the best ones for doing this sort of thing. And the way we figured out what they were made of was by looking at them at different types of light. Sometimes we looked at the blue, sometimes we looked at the red, sometimes we looked at the infrared. And as we compiled all of this data and over the course of that were taken over the course of years, we actually were able to piece together that this moon was bright at specific wavelengths, that is, bright where ice is bright, and it's dark at specific wavelengths where ice is dark. So, yeah, it was definitely a lot of work to pull all of that data together.
Wow. Okay, so my question is, how does a discovery like this help us better understand maybe how the solar system was formed?
That's a good question. The one of the big so this is of course stuff going on currently today. But the objects that we are talking about here have been formed in a very different part of the solar system, in a place that's very cold and very dark. One of the big things that we still don't fully understand about the outer solar system is what is all of this stuff made out of? Some of we know that water ice is fairly common out there, but what other materials are out there? Are they rock? Are they carbon compounds that are kind of like coal? And what are the mixes of those? That's been something that's been really hard to study. And in part, it's because everything's covered in stuff. There are asteroids and meteorites going around and constantly covering everything in similar sorts of dust. For things like these dusty rings, something is releasing material. And that might be exposing stuff from inside these objects, which can help us figure out what they're actually made out of, which tells us something about what the outer solar system was put together from. So that's how it would tie to that kind of question.
Nice. Nice. Okay, do you think these rings may be changing over time? I think I read that you found out one of Saturn's rings, the D ring, has been changing. Could this be true for Uranus?
So one of the big things from this study is it looks like the brightness of the mu ring is changing with time. And we previously did analysis that found another of these dusty rings seems to change over time. These are tenuous rings, so the way they are easier to change because they're just less material to work with. What is going on, though, is we still don't know what exactly changed. For example, maybe either the moon or some other ring got hit by something in the last decade or something that kicked off material, or maybe something else has happened that is harder to see. We currently can think about stuff hitting them, so that's the idea we're currently working with. But is something else changing within them? And just to say, we are planning to just monitor these things and keep watching them and see how they change over the next few years to better understand that.
And you're going to keep looking at the planet, right? For a few more years.
Oh, yeah. Yeah, we are part of a program now that is going to look at the planet every year for the next 5 years with these great telescopes.
Wow. I envy you your job. Thanks, Matthew, for coming back and telling us more about these rings.
Well, thanks for having me, and happy to always talk about this stuff.
We've been speaking with University of Idaho physics professor Matthew Hedman about his discovery, along with others, of the 2 new rings around Uranus.
Thanks so much for listening to this episode of Idaho Matters. And for quick news of the day, start your mornings with our podcast. It's called The Connector, Idaho Daily News. Just by listening, you're helping to support public radio right here in Idaho. And I want to say a big thank you for that.
Each story you hear on Planet Money starts with a question. What happens if we refund tariffs? Why are groceries so expensive? At NPR, we stand for your right to be curious, because the forces shaping our world can be hard to see. Follow NPR's Planet Money wherever you get your podcasts and start seeing how the economy really works.